Welcome to the PECO Virtual School. Our topic of discussion today is matrices. Our mode of operation: you watch the tutorials. After you've watched the tutorials, you're supposed to attempt an exercise that is always available at the end of the tutorials on request. So the facilitator today is Mr. Tunomigisha Lambert, and our contacts for PECO Virtual School are available on the screen. So feel free to contact us for any issues, for any supplements. We have tutorials for all the O-level subjects: physics, chemistry, mathematics, biology, to mention but a few. All the O-level tutorials are very available, so feel free to contact us in case you're interested in one. Watching the tutorials alone may not help. We need to evaluate and see how much knowledge you have gained from the tutorials. So matrices, we shall begin by defining what a matrix is. So a matrix is a rectangular arrangement of numbers in terms of rows and columns. The simplest example of a matrix that you can think about is the classroom arrangement. How many rows and how many columns are in your classroom? Try to make that flashback. How many rows and how many columns are in your classroom? That will give us an insight on what a matrix is. So when you talk about a matrix, you're looking at the rows and columns. So rows are horizontal, whereas columns are vertical. If I may ask, which student sits in the first row, first column of your classroom? First row, first column of your classroom. That student should be the student that once you enter the classroom, that student on that very first locker will be in the first row and the first column, keeping in mind that rows are horizontal whereas columns are vertical. So when you look at this example, I have this example here. This is an example of a matrix. Why is this one a matrix? It is a matrix because it has rows. Now this is the first row. I said rows are horizontal. This is row 1. This is row 2. So the elements in row 1 are 1 and 2. The elements in row 2 are 3 and 4. The elements in column 1, now this one is a column. 1, 3 is the first column. 2, 4 is the second column. So we also have this other matrix. You can realize that now the sizes of these two matrices are different. This matrix has 1 row, 2 rows. It has 2 rows and 2 columns. Whereas this matrix has, this is the first row, second row. So it has 2 rows. And how many columns? We can check. The columns are 1. This is 1 column. This is the second column. And this is the third column. So the first matrix has 2 rows and 2 columns. The second matrix has 2 rows and 3 columns. So in a matrix, when I consider this matrix here, the elements 1 and 2 are in the first row, whereas the elements 3 and 4, 3 and 4 are in the second row. Now when you check this other matrix here, our second matrix, you realize that these elements here 1, 2 and 0 are in the first row, while -2, 3 and 5 are in the second row. So this is our first row, second row. Now this one here is our first column. This is column 1, this is column 2, and this is column 3. So if I want the elements that are in the third column, that is 0 and 5, those elements are in the third column. Now if I may ask, referring to this matrix, I want you to answer this question: which element is in the first row, second column? Which element is in the first row, second column? Which element is in the first row? Now this is first row, second column. The element is actually 2. The element that is in the first row, second column, is actually 2. If I'm to ask which element is in the second row but third column, second row but third column, this element is 5. The element in the second row but third column is actually 5. So when we are dealing with matrices, it is very important that we appreciate what a row is and what a column is. The knowledge of rows and columns are going to be very important as far as matrices are concerned. For instance, when we talk about the order of a matrix, the order of a matrix is defined by the number of rows and the number of columns. E.g., if a matrix has 2 rows and 3 columns, then we call it a 2 by 3 matrix. 2 by 3 matrix. So the first entry is for the rows and the second entry is for the columns. So this is the number of rows. So if I say 2 by 3, strictly the 2 are the rows and the 3 represents the number of columns. Similarly, a matrix where the number of rows equals the number of columns is given a special name. Where you find that the number of rows are equal to the number of columns, that is a special matrix. We call it a square matrix. E.g., if a matrix has 2 rows and 2 columns, then we call it a 2 by 2 matrix. Now this one is a square matrix. Why? The rows are equal to the columns. The number of rows and the number of columns are equal. If a matrix has 3 rows and 3 columns, then we call it a 3 by 3 matrix. Now these are square matrices. Why? The number of rows and the number of columns are actually the same. Now we can look at addition and subtraction of matrices. Before we do addition and subtraction of matrices, we need to note that matrices can be added or subtracted together strictly on one condition, if and only if their orders are the same. So I can add or subtract matrices if and only if they are of the same order, meaning that they must be of the same number of rows and the same number of columns. So to add or subtract matrices, we add and subtract corresponding elements, as we can see in our first example. So example 1, we have matrix A, and then our question is, if matrix A equals 3, 2, 1, 4. State the order of matrix A. So I want to state the order of this matrix. So if I want to state the order of this matrix, I must find out how many rows are in this matrix. So this is first row, second row. So this matrix has 2 rows. First row, second row. First row, second row. So it has 2 rows. And how many columns? This is first column, second column. So the matrix has 2 rows and 2 columns. Therefore, the order of matrix A is 2 by 2. Why? It has 2 rows and 2 columns. This matrix here has 2 rows. This is the first row, second row. So 2 rows and how many columns? First column, second column. So we call it a 2 by 2 matrix. We can look at the second example. We have matrix P. So we also have matrix Q. And we also have matrix R. So the first question we need to get matrix P plus Q, matrix Q minus R, 3P minus 2Q plus R. So the first question, P plus Q, we need to find out is the order of P the same as the order of Q? This is a 2 by 2, this is a 2 by 2, so which means that we can ably add those matrices. So we are going to add, since the orders are the same. That is the first condition. If the orders are not the same, then you cannot add or subtract. So our addition and subtraction will depend on whether the orders are the same. So we are going to add elements in the same position. So I will get this one and I add it to this one. First row, first column. First row, first column. First row, second column. First row, second column. So we shall add 1 plus 1, 0 plus negative 4. Then 1 plus 3, negative 2 plus 2. That's how we shall do the addition. So we shall take 1 plus this one. Then 1 plus 3. Then 0 plus negative 4. And then negative 2 plus 2. And once you get to this level, the remaining work is just computation. We just add. So we shall have 2 there. Then we shall have 4, negative 4, and then 0. Now that is our P plus Q. So let me repeat the steps. 2 matrices can be added or subtracted together if and only if they have the same order. If it is a 2 by 2 matrix, then you can add it to a 2 by 2 matrix. If it is a 2 by 3, then you can add it to a 2 by 3. If it is a 3 by 3, then you can add it to a 3 by 3. If the orders are different, then there is no way you can add or subtract matrices. That is the first condition. Now, having looked at the addition and subtraction of matrices, we can ably look at multiplication of matrices. However, the condition for multiplying matrices is different from the condition for adding and subtraction of matrices. And the condition is clear. Matrices can be multiplied together if the number of columns in the first matrix equals the number of rows in the second matrix. Otherwise, matrices cannot be multiplied together. So we can illustrate that using these 2 matrices. I have matrix P and then I have matrix Q. What is the order of this matrix here? How many rows does it have? This is the first row, second row. First column, second column. So this one is a 2 by 2 matrix. Come to Q. It has 2 rows and then 2 columns. So this is a 2 by 2 matrix and this one is also a 2 by 2 matrix. So these 2 matrices can multiply. Why? The number of columns here is equal to the number of rows in the second matrix. P times Q is possible because the columns in P are equal to the rows in Q. So we can take an example of matrix A and matrix B. So we can look at this. What is the order of matrix A? How many rows? This is 1, 2, 3. 3 rows. And how many columns? 1, 2. 1. This is the first column. This is the second column. First column, second column. First column, second column. So it is a 3 by 2. 3 rows and 2 columns. Come to this. How many rows? 1, 2. 2 rows. And how many columns? 1, 2, 3. So this is a 3 by 2 and this is a 2 by 3. Are these matrices, is A times B possible? The answer is yes. Why? You realize that the columns here are 2. These are 2 columns. And the rows here are also 2. You can see this. This is 2. This is 2. So columns in the first matrix are equal to rows in the second matrix. That is the condition. As long as these figures are the same, it means that the matrices can multiply. This is 2. This is also 2. So 2 columns in the first matrix and 2 rows in the second matrix. So multiplication is very possible, since the number of columns in A, which is 2, is equal to the number of rows in B, which is also 2. Can we now take some examples? We have the matrices A and then B. So the first question, we want the order of A. Find out how many rows are in matrix A. So how many rows are in matrix A? Matrix A has 1 row and 3 columns. So it is a 1 by 3 matrix. Matrix B has 3 rows and 1 column. So it is a 3 by 1 matrix. How about if I multiply A and B? So when you multiply a 1 by 3 with a 3 by 1, so we are multiplying this and this, a 1 by 3 and a 3 by 1. The answer of the product should be this value here, which is 1 by 1. This is what gives us the order. So the order of the product is this, 1 by 1. So when I multiply A and B, I'll end up with the 1, this value and this one. Why? This and this are the same, meaning that the matrices can multiply since these columns are equal to these rows. So the number of columns here is equal to the number of rows. So number of columns is equal to number of rows. So this and this are the same. That is the condition for multiplying. This and this are the same. So if this and this are the same, then now the product will be this, will be of order 1 by 1. That's the condition we use. So we are now going to multiply A and B using the same principle, and the multiplication of matrices is actually simple. We use row by column. Get a row and multiply it into a column. So I'll get this row and multiply it into this column. So I'm going to get 2 times 1, 2 times 1 plus negative 1 times 3 plus 4 times 4. This is the procedure we shall use. So we shall have 2 times 1 plus negative 1 times 3 plus 4 times 4. So the remaining work is just computation here, and then we shall end up with our final answer as 15, because when you put this is 18 plus negative 3, that gives us 15, which is actually a 1 by 1 matrix. We can extend that idea put another matrix here. So we have matrix A, we have matrix B. So we want to find AB and then BA. So AB is simply A times B, so we shall say matrix A times matrix B. So the matrix A is here, the matrix B is there. So we just, where there is A, we put that value. Where there is B, we put that value. Now we are going to use the same concept of multiplication. We are going to multiply row by column. So I'll get this and multiply it into this row into this column. So I will take 2 times 6 plus negative 1 times 10. Then next 0 times 6 plus negative 1 times 10. Let me repeat, 2 times 6 plus negative 1 times 10. Then I proceed to the second row. 0 times 6 plus negative 1 times 10. We don't end at that. I will again get this 2 times 8 plus negative 1 times negative 12. 2 times 8 plus negative 1 times negative 12. And then finally we shall look at the second row, second column. So 0 times 8 plus negative 1 times negative 12. Now once we get to this level, the remaining work is just computation. So this is 12, this is negative 10 giving us 2, this is 0, this is negative 10, this is 16 plus 12 giving us 28, this is 0 giving us 12. So the second question, B times A, shall use the same approach. Put the matrix B, put the matrix A. Now we use the same principle. Let us now retrace the steps we did in the previous question. So we shall take this row into this column. First row, first column. First row, first column. First row, first column. First row, first column. So 6 times 2 plus 8 times 0. Now I come to this 10 times 2 negative 12 times 0. We don't end at that. I must also get this row and multiply it into this column. First row, second column. So 6 times negative 1 add 8 times negative 1. Do the same thing for this row. 10 times negative 1 add negative 12 times negative 1. So we shall end up with, that is 12. So we do computation and we end up with those values. So the most important part as far as matrix multiplication is concerned, we need to always remember that when you're multiplying matrices, you always multiply a row into a column and you must exhaust all. First row, first column. First row, first column. First row, this is the first row, I multiply it into the first column. This is the first row, I multiply it into the second column. I go back to the second row. Now this is second row, first column. Second row, second column. And you come to that. And that is the only principle we apply when we are multiplying matrices. So when you check A and B, then B and A, you realize that in matrices, A times B is not the same as B times A. So when you multiply A and B, then it will not be the same as B times A. That property only applies to matrices, that A times B is not the same as B times A. We can now take the next question. We have a matrix P there. We have a matrix Q. And then we have a matrix R, which is P times Q. So we can study that question. Before we begin answering, You can try to investigate what is the order of matrix P. Ask yourself that question. What is the order of matrix P? How are you going to derive the order of matrix P? You look at the number of rows. How many rows are in matrix P? And how many columns are in matrix P? So this is row 1, row 2. So it has 2 rows. And how many columns? 1, 2, 3. So therefore, matrix P is a 2 by 3 matrix. 2 by 3 meaning that it has 2 rows and 3 columns. How about matrix Q? How many rows do you see? Rows are horizontal. So this is the first row, second row, third row. First column, second column. So meaning that Q is a 3 by 2 matrix. We can check that. So matrix P has 2 rows and 3 columns. I mentioned that. These are the rows. 1 row, second row. Columns, first column, second column, third column. So this one is a 2 by 3 matrix. How about Q? Q has 3 rows. You can see 1, 2, 3. And how many columns? 1, 2. Columns are vertical. This is 1, this is 2. 1, then 2. So it is a 3 by 2 matrix. Now, if you multiply P and Q, we shall get matrix R. Now, I want to find out what is the order of R. We can derive that from here. R is P times Q. Now, P is a 2 by 3, Q is a 3 by 2. Now, you realize that these figures are actually the same. This is the condition. That multiply matrices, this value and this should be the same. So, it has 3 columns here. P has 3 columns. And Q has 2 rows, so meaning that P and Q can multiply. So the 3 and the 3 are the same. We can multiply, meaning that the product will now be of order this value, which is 2 by 2. So R will be a 2 by 2, this and that. So R will be a 2 by 2, 2 by 2. So R will be a 2 by 2 matrix. Derived from this, that P times Q, since the columns here are equal to the rows here, then the R will be a 2 by 2 matrix. So can we now get the matrix R? We shall just multiply, since we've already found out that the matrices can multiply. So we can now check first row, first column. You can check that. First row, first column. When we are multiplying matrices, we multiply row into columns. First row, first column. So once I take the first row and the first column, realize that we shall have 3 times 1 plus 1 times 0 plus 7 times 5. That's what we shall take. 3 times 1, 1 times 0, and 7 times 5. We proceed to this one here. Negative 1 times 1, 3 times 0, and 2 times 5. We now proceed to this. 3 times negative 1, 1 times 3, and 7 times 2. We come to this. Negative 1 times negative 1, 3 times 3, and then 2 times 2. And what remains is now the computation. So once we compute, we end up with the 38, 14, 9, 14. And this one is actually, a 2 by 2 matrix, as we had earlier said. So R is actually a 2 by 2 matrix. Now that takes us to our next example, which is example 4. We have those matrices provided. So question 1, determine the order of matrix AB. Now we said that AB is A times B. Now before you get the order of A times B, you must be in position to tell the order of A. You must be in position to tell the order of B. Can you do that? The order of A. Try to find out that. What is the order of matrix A? How do you state that? Look at the number of rows and the number of columns in matrix A. How many rows can you see in matrix A? 1, 2, 3. 1, 2, 3. 1, 2, 3. First row, second row, third row. So it has 3 rows. How many columns? 1, 2. So meaning that A is a 3 by 2 matrix. How about B? How many rows do you see? 1, 2. 2 rows. And how many columns? 1, 2, 3. So B is a 2 by 3 matrix. Now we check it here. A 3 by 2, B 2 by 3. So meaning that A and times B is very possible. Why? The number of columns here are equal to the number of rows. You can see it here. These columns here of matrix A are equal to the rows of matrix B. So this is 2, this is 2. They are actually the same. So this is 2, this is a 2, meaning that A times B is very possible. Why? The number of columns in the first matrix should be equal to the number of rows in the second matrix. And the A times B will now be, see this figure that is here, a 3 by 3 matrix. It will be a 3 by 3 matrix. So the product A times B will be a 3 by 3 matrix. So our multiplication should give us a 3 by 3 matrix. So we can now proceed with our multiplication using the same approach, row by column. This time we have to do more work because the rows and the columns are many. So we shall have 1 times 2 plus 2 times 1, which is here. Now we proceed to this. 3, can see the 3 times 2, 3 times 2 plus negative 1 times 1. 4 times 2 plus 5 times 1. Now we proceed. 1 times negative 1 plus 2 times 3. Now we come to this. 3 times negative 1 plus negative 1 times 3. Proceed. 4 times negative 1 plus 5 times 3. We have not exhausted all. We still have this column here. So we shall take 1 times 4 plus 2 times 1. 1 times 4 plus 2 times 1. Now we continue. 3 times 4 plus negative 1 times 1. Then 4 times 4 plus 5 times 1. Now we've exhausted all the rows and all the columns. Now once you get to this level, the most important part is now to compute and get the final answer. So once we do the computation, we can find out if it takes us the same. This is 2, this is 2, giving us 4. This is 6, negative 1, giving us 5. This is 4, 2, giving us 6. This is 6, negative 1, giving us 5. Negative 3, giving us negative 6. 12, negative 1, giving us 11. 8, 13, negative 4, 15, 11. 16 plus 5, giving us 21. So that marks the end of our first lesson on matrices. However, feel free to contact us for more exercises and examples as far as matrices are concerned. However, we have tutorials for all the subjects. You can always reach us on our contacts that have been provided. However, before we look at the exercise, we could also include this question to help us ascertain how we can handle squares. So we have the matrix P there. We have the matrix Q, and we are interested in P squared Q. So once we say P squared in matrices, it means P times P, and that's what we are going to do. So I have the matrix P times another matrix P. That's what we have. Now apply the same concept of row by column. So we have row, then by column, row by column. So we shall take 1 times 1 plus negative 2 times negative 1. We proceed to this negative 1 times 1 and 3 times negative 1. We don't end at that. We shall now take 1 times negative 2 plus negative 2 times 3. We proceed negative 1 times negative 2 plus 3 times 3. And at this level we just compute to give us a 3 there, negative 8, negative 4, and then 11. So P squared Q, we have the P squared. Now the P squared times the matrix Q to give us matrix R. So we can check before we multiply, is the multiplication of these matrices possible? We can see that. Is it possible? We can check. How do we check that? How many rows and how many columns are there? So this matrix is a 2 by 2. Why? It has 2 rows and 2 columns. How about the second one? 2 rows and then 2 columns. So meaning that the multiplication of these matrices is very possible. So we can now proceed and use the same concept of row by column. So 3 times 2 plus negative 8 times 0. Then negative 4 times 2 and then 11 times 0. We proceed to this now. 3 times 0, negative 8 times 2. Then negative 4 times 0 plus 11 times 2. We now compute to have 6, negative 8, negative 16, and then 22. So our matrix P squared Q is 6, negative 8, negative 16, 22. Feel free to contact us on the numbers that are available on your screen. For all the subjects of O level and exercises, you can call 0782 61 3593, 0705 286 153. Thanks for watching. Beko